Right, good afternoon. No, wait, no. Good morning. Hey, where them downstairs? Some of them downstairs? Oh. Right. Morning online. You're here in that take all the time. If you train clothes, I gotta walk around. For what? In the kitchen? The to wash your hands. Right. Morning. You're here and online there.
Yes, sir.
Yeah, okay, nice. So lastly we did electricity, we did it theory behind all the quantities, current, voltage, and no. That's separated now. They hand from this one. Like awesome. All right. So what I wanted you all to do ideally was to look back at the things on current and voltage and thing, right? But hopefully you all would have done that before class, right? So let's continue with electricity, right? Today we move into the calculation side of things, right? Did I talk about series and parallel? I think I did, right? Right. So I talked about series and parallel. We talked about current. What was I? If you had to give that definition, I was what? Very good. I was charge flowing per unit time, right? And the SI unit was amperes. Voltage was what? What was voltage? R? No, R is distance, right? What was voltage, like in your own words? What was voltage? The amount of energy, you can take energy, the amount of energy supplied to the electrons, yeah, that kind of work, right? So we can say the amount of energy applied given to a charge, SI unit is volts, and resistance is what? Resistance is in ohms, and it controls the amount, right? It controls the amount of electrons flowing in the circuit, and I told you R was equal to VI. Okay, so we had a few relationships that we came up with. Q is equal to IT, W is equal to VQ, and V is equal to IR, right? That's if we rearrange all these little formulae here, right? So those were some of the things that we came up with. We also talked about series and parallel, series circuit, and we have parallel circuits. Copy down this circuit and change it quick there. No, but it's really cool. Huh? No, that's just me. Since I come back from the code, I'm feeling cool for everything. That's just me. All right, good. So we talked about Vishal. When Aisha? Let's call Aisha. Come on, please. Nisha, she downstairs. Just tell them two of them are physics. Right? And the next thing we talked about was series and parallel, right? So actually head up resistance in series and resistance in parallel, right? head up resistance in series and resistance in parallel. I did not give you these formulas, right? So let's take a look at resistance in series first. Right? So I'm going to draw a simple circuit here for you for resistance in series. We talked about what will happen already. Let's make it simple. Let's put two resistors in series. Let's call this one R1. Let's call this R2. Right. By the way, what direction is current flowing? Here's the positive and here's the negative. What direction is current flowing? So. Right. So it'll go from positive to negative. Right. Remember that's conventional flow. But that's not clockwise, anti-clockwise, right? So that's conventional flow, right? What do we know? What do we know about current in series and current in parallel? It'll take so long to come upstairs. Oh, shucks, the door wasn't opening. Oh, yeah, that would take off that way. And I'm gonna take it off because I hear that sticking now. Current in series and yeah, what do we know about current in series again? Yeah, anybody? Anybody online could have two current in series, what we know? Current in series is the same, right? So the current going through R1 is the same current going through R2. By the way, how do we measure current? How do we measure current in a circuit? Using a what? Ammeter connected in series. Yeah, man. Right? And your voltmeter is connected in parallel. Right. What about current in series? Sorry, voltage in series. Voltage in series will split up, right? So voltage in series splits up. Okay. Now we're going to learn about resistance. Right? Resistance in series. So to find total resistance in series, we add up the values. R1 plus R2. Anybody else? Someone? Okay. So the resistance in total is R1 plus R2. If all you can't see, look at how much seats in front. Look at how many seats in front. Or they come right there. It's not even considered front. That's all it is. Let's straight all that is it. So basically series, those are the rules there for series, and we're going to do a couple of questions, right? Copy it down. For those who don't remember, write down the ammeter is connected in series, voltmeter is connected in parallel. Yeah. Because of all night, no, done.
No, but like what?
No.
You can't have no mirror.
Exam time.
No, but what I'm thinking, you say about one like
Yeah, I saw it for everything. Much hard math.
but on different days or
So all I have sitting on the different days. Doing that timetable. I'm gonna put out a timetable. That timetable is also crash course. Crash course is during Easter. Not that different. Crash course is
like that.
right, but there's a little more in depth. Then I'll put out the all nighter timetable.
No problem.
Anybody writing? You're finished. So we're going to use those rules now to find some values, right? All right. What do I write inside? Hurry up, no boy. So we're going to use all those relationships together with this new one here, this behavior, right? Ready? Ready, right? All right, so I'll give you some values here. I'm going to give you a voltage, right? That's the battery and the voltage is 10 volts. We'll close up this switch and I'm going to give you two resistors here. One is 4 ohms and one is 6 ohms. Okay. So the first question I'm going to ask is I want to get help to find the total resistance. Right? Those two resistors are connected in what? Series. So how are we going to get the total resistance? Add them up, right? Very good. So you can write the formula R1 plus R2. So that will be 4 plus 6, and the answer is 10. That's okay? Okay, Sharp, you okay with that? So I need a little help now. I want the current in this circuit. I want to get the total current to be exact. Total current. Tell me what to do. Huh? Right. So the total current, the formula is I is equal to V over R. Could I use Q over T? Could I use Q over T? Yeah? No, because I don't have Q and don't have T, right? I wouldn't be able to use that, right? So I is equal to V over R. So V is how much? 10. R is 10. So the answer is 1 ampere. Notice when I'm working this out, I'm working in the SI units, right? All right. All right, number 3 now. Let's make it a little bit harder. Here's what I'm doing, right? For number 3. I'm going to take a voltmeter, right? And I'm going to connect a voltmeter right here. Right there. So I want to find, let's see if we can find V1. I want to find V1. Yeah, same values, but it's some ideas. Help me out now. How you find voltage? Voltage is what? I by R, right? Good. Question. V1 is across which resistor? Which one? The 4 ohm resistor, right? So the voltage, the voltmeter is across the resistance of 4. Right? Question. What is I? What is the current flowing through the 4 ohm resistor? What is the current flowing through the 4 ohm resistor?
So it's the same, I don't know,
It's the same as
1.
1. The same value because we just found this, right? Current flowing in the circuit is 1 ampere. Same current here, same current here. How we know that? Right? If you remember from last
Because
week.
it's in series.
Yeah, right? Current and series are the same, right? We did that the week before. If you're confused or you forget, look back at the video, please. Right? It was important that you look at the video before the class, but can't do anything now. Right? So V1 is how much? V1 is 1 by 4, which is 4 volts. That's okay, Arya? You okay with that? Right, Arya. I need some help now. I need some help to find V2. I'm going to connect our next voltmeter here. Right? What happens to voltage in series? It splits up, right? So if V1 is 4, what do you think V2 will be? What was the total voltage in the whole circuit? 10, right? So if V1 is 4, V2 will be 6. Very good. Right? You're seeing that? You can even calculate if you want. Right? You can even calculate it. Hisham, you okay with that? Copy it down. Ready? Going again, some very similar. Right, so what I did here for you, I kind of break it down in steps, right? I'm going to add one more resistor here now. Same principle. Right, this is 12 volt supply. And instead of one resistor, 2 are given in 3. And I'm connecting a voltmeter across this one. This is 2. This is 4. And this is 6. 6 now. 9.6. I put in 3. Put in 3. 3. I'll take out 3. Because you end up getting fractions and things.
So you may have to do everything.
But you will still get fractions around finish. 0.8. 248. Right, a 0.8, right? So we have a few things to find. We have a few things to find here. I would like you to find number 1, total resistance. Number 2, total current. Number 3, find the voltage in P1. Right, find the voltage in V1. Hurry up. I won't take it long. Right.
Well, I need this part here. So, you can that's my.
And let's see what we have. Okay, let's see what we got. So this is everything here is series so far, right? Part one, the total resistance. We just adding it up. 2 plus 4 plus 8. That's 14. Next one, total current I is equal to V over R. So that's 12 over 14. You can simplify it to 6 and 7 amperes or decimal, yeah. Right? And what's the next one? Right, V1. V1 is equal to I by R. Current is the same, and the resistance is 4. So that's 24 over 7 volts. Right, you can break it down if you want, up to you. 3 and 3/7 or whatever, right? Yeah, decimal could work. I just don't want to have to round off in between, so I like to leave it as fractions. Okay, nice. So that's the first part. That's number 1, 2, 3. Good. Now for parallel, right? Let's take a look at a parallel circuit. A parallel circuit is identify parallel circuits by looking for junctions. When you have a junction and the current has more than one direction to flow in, that's a parallel circuit, right? Right? What do we know about parallel circuits? Number one, current what? Current is the same or it splits up, right? So current splits up. Second thing, what do we know about voltage? Voltage is the same, right? Voltage is the same. And well, I'm giving you total resistance formula now. It's a little bit different. Is 1 over R is equal to 1 on R1 plus 1 on R2. Right? That's the two resistors, right? That's for two resistors. Okay, so those are the rules that you need to know about series and parallel, right? Current splits up. So what that simply means is this. If you have current flowing in here, that current will split up into two values, I1 and I2. So if you were to try to find back I, you just have to add up I1 and I2. Right? If you had a voltmeter here, if you were to connect a voltmeter here and connect a voltmeter here, all the voltage bars would be the same. So I just put in V1 and V2. Right? So V will be equal to V1 and V2. So the voltage across any of those will be the same. Right? So just to play around some numbers to make sure you understand. If here is 12 volts, if here is 12 volts, here is also 12 volts, here is also 12 volts. Are you okay with that? They all carry the same voltage. All right, just make a note of that. Right, let's try one. I said I'll give some numbers here. Right, so the total is 12 volts. Here is 3 ohms. And here is let's make the working simple, right? 2 ohms. So part 1, I want you to try to find total resistance. And then part 2, I want you to find current in the 3 ohm resistor. Try that on your own first. I'll help you. Ready?
Yeah.
Ready? So let's try it, right? 1 on R is equal to 1 on 3 plus 1 on 2. 1 on R is everything is over 6, right? So that'll be 2 plus 3. So 1 on R is 5 on 6, but that's not your answer. You have to flip it over, right? You have to flip it over. So R is equal to 6 on 5 ohms, right? Or you can write 1.2. Right. Now, current. We know current is voltage and resistance, right? The resistance here is 3, but what's the voltage across that 3 ohm resistor? How much? 12. Why? Because voltage and parallel is the same, right? So 12 on 3, that'll give you 4 amperes. Basic. Right? Nice. Huh? Why put what over 6? I found the LCM here. Find the LCM. Copy them quick. Right now, let's combine them a little bit. In fact, let's do one more. I'm not combining it as yet. Oh, quick question. Current here was how much? 4 amperes, right? What's the current here? No, underneath. The 2 ohm resistor. What's the current there? 12 divided by 2, which is? So what's the total current in the whole circuit? Elena, what's the total current in the whole circuit? How much? 10. 4 and 6, right? 10. Keshav, you okay with that? What you'll recognize there, the smaller the resistor had a larger current or smaller current? Larger, right? So you remember the definition for resistance, it controls the amount of current in the circuit. So a high resistance, low current. Low resistance, high current, right? Don't forget that, right? Yeah? Next one is yours, right? Will you come later? I think everybody else do one already. Your turn. That's 1, 2, and 3, right? Take your time with the fractions, right? Huh? Then nothing.
See, they give you a question like that, and then you're working it out and the switch over.
Right, follow, don't forget to subscribe to the YouTube channel. I reach it, you know, say I reach 1,000 here.
You sound like that American guy.
Yeah, I just had to put that in now.
Come on, sound like an American girl.
I had to remember that.
Don't forget to subscribe to my YouTube channel.
No, I didn't realize, I think reach 1,000.
Yeah, they got a fee.
So that way I'll get better space and I'll be able to store more things there now. How much I have? About 20.
So like, so what she trying to tell you is you're boring now. So what she trying to say, yeah, you can do and I'm boring now.
I didn't start editing anything. I didn't start editing until I'm just using these raw videos. Man. By the way, you subscribe and just make people subscribe. Just take your phone and just press subscribe. Wait, now if all your alone subscribe, that should be a couple hundred right there. I gotta send a message here. If I don't see a sub. No, I have like keep I like 100 on it. So I have plenty of them. It's not a thing, it's just notes right now. Videos on it. I will start to edit later on. Right, what we're waiting on? Yeah, Jaden. This one belongs to you. Take your time, no rush. Right, I want the total resistance. You can leave it as a fraction and the current. Right, all I'm gonna do now to make it more complicated is to put series and parallel together. That's all. Right? That's all the past papers will do, put series and parallel together.
So, but then you get one.
So what you have to do when they put series and parallel together is to turn the circuit all series or all parallel. I'll show you. All right?
So what can you put in the room?
I give all the muscle work. Crap. I give you one person bad math.
No.
Oh, this thing, serious man, are the video.
So what you put down and they will do one.
What's that?
One roll.
No, something wrong.
No, because then 3 at 3 6.
Right, so let's check out total. Yeah, all right, let me check it out here.
Yeah,
So it's 1 on 1 plus 1 on 2 plus 1 on 3. So the LCM is 6, right? And then you will get 6 plus 3 plus 2. So 1 on R is 11 on 6, right? So R is equal to 6 on 11, right? Use a calculator, look for your shame, check it back, yeah? Use a calculator and plug it in. Right, what's the next one? Current across the 2 ohm resistor. So I is what? R is V over R. Voltage in parallel is the same. So voltage is 6 and R here is 2. So the answer is 3 ampere. Okay with that? Yeah, good. Let's combine them into one now. Any questions online? Right, let me see who I'm messaging. Let me put them in a little room there. Jason, let me boot out Jason. And let me boot out who else is anything. Shivani, you there? Zane, Smike, you there? No, not Shivani, the next one, Sharavani. Right, just message and let me know you're there, please. Zane Smike, let me move out. Zane Smike there. What should you apply? What should you reply? Fast. All right, next one. Right. Look at this circuit here before I ask you to work it out, right? What you recognize about this circuit? What you can say about the 2 ohm and the 2 ohm? They are in what? Series, right? So and this underneath, man. So you have 2 and the 2 in what? They are in series, right? So and it's easy to combine them into one. And then when you combine that into one, then you have those 2 in parallel, right? That's okay. So sometimes I like to do this. You don't have to, but I just like to have a simplified circuit. Right? And then do the simplified circuit and find anything else you need. Right? So here's what you're going to do for me. Number 1, you're going to find total resistance. And then number 2, I want you to find the voltage across the 4 ohm resistor. Go ahead. Just give it a try. If you get in trouble, don't worry, I'll help you.
It's same 10 volts,
Hmm?
Same.
Same 10 volts. Yeah, I didn't change it. Same 10 volts. Yeah. Ah, the original 4 we're talking about. The original 4. I'm talking about the original 4. Yeah. Okay, that fast. Right, so they have here. So you have here. Yeah, want to? Next one. Yeah, so. That's all. So, where was all that? That's the voltage, no, not current. You will the current. So again, let's see what you got. Oh gosh, yes, please. Figure out what I do wrong, right? All right, let's see what we got here. Total resistance, as I said, I want to simplify the circuit. So the bottom stays 4 and the top is now 4, right? 2 plus 2, right? Because these two are in series. So therefore, the total resistance is, I could use they are in parallel. So I could use the parallel formula. So that'll be 1 on 4 plus 1 on 4. So 1 on R is equal to 2 on 4 or a half. So R is equal to 2 ohms. R is equal to 2 ohms. Now I want the voltage across this resistor, but those resistors are in parallel, right? So remember that voltage in parallel is the same. So therefore, voltage in parallel is the same. So it means that the voltage is simply 10 volts. Nothing to work out. For 1 mark, no, there's more than 1, yes, right? Okay, now we could jump out into some big questions, past papers. Right, anybody have a booklet here? Do I have a booklet here? I think I have. Right, so we could start past paper.
Oh, no.
All right, so let's try this one here. That on the screen. John 2010. I will give you the whole circuit. We will just doing the calculation part, right? Do you all want the slides? Anyway, I'll just save them on standard.
Yeah, something.
Extend it. Much of my thing, I have to use this button now to use. Right, so let's try 2010. Oh, really? Wait, really? I need doubles in a year. Yeah, I know doubles. Don't you rule on the cloud doubles. Right, give it a little try. What you recognize about this distance? What you can say about R2 and R3?
Switch on the report.
R2 and R3 and parallel. So my advice to you is to take R2 and R3 and make them one. So,
Switch on the report.
so no, they will close it. Right? They close the circuit. Huh? How we make it R2 and R3 and use the resistance formula parallel. Use the resistance formula parallel.
You know that it might be a blue.
Right? Massive.
It's another ring.
So you're muted.
Okay. All right, I'm starting over. Sorry then. I was muted. Sorry about that. What I was trying to say is right. When you close the circuits here, right? When you close the circuits here, current will flow. Current will flow here, and when the current reaches this junction, the current is going to split up. So the current will split up here and here.
Yeah.
You better now. With me.
Wait, can you draw, right?
Yeah.
I'll leave this. Sorry.
Right? It will split up here and here, right? So you will end up with R2 and R3 being in parallel, right? That's how you know parallel. When you have different currents flowing, it means that they're in parallel, right? So now you could use the parallel formula. 1 on R plus, sorry. 1 on R is 1 on R1 plus 1 on R2, and you will end up with the resistance, and you'll be able to simplify this into one resistance. And your circuit now looks like this. One big bulb here, one here. And they are now in what? They are now in series. And it's easy for you to work out the total, right? And then they want you to find total current after that. Oh, yep.
Each ball is.
Each bulb is
1,000.
1,000 ohms. Yeah. Try that fast.
Today was 2,000, 92,000. Series.
You work it out. I mean, you do your thing. You do your thing, and then I will do my thing.
It is about 2 more, which is 1,000. We give it 2,000. Because if it's not in series, which is not in series.
Oh, so you find the total resistance already? Let's check it out now. So working out the first two, that'll be 1 on R is equal to 1 over 1,000 plus 1 over 1,000. So that'll be 2 over 2,000. So R is equal to 1,000 over 2, which is 500. So one is 1,000 and the next is 500. So the total resistance since in series will be 1,000 plus 500. 1,500 ohms. Okay. Last thing, current drawn. If all the bulbs are lit, current is what? Voltage over resistance. So that's 110. 110 over how much? 110 over 1,500. How much is that? 11 and 150. 11 over 150 amperes. Or you can put a decimal. Anyone you want. 11 over 150. Let's go again. We got time. What are we doing? What are we going on? I don't know to work until Monday. Yeah. All right. I was saying next number homework fair. Yeah. Yeah. I'm good at anything. You're still gonna have that work. You want to leave?
Oh.
All right, let's try our next one here. Wait, I went the wrong way. What's the year that we just said? 2000. Oh, there's the old book. Oh, that's right. That was 2010. I have to run and get a new book. Yeah, right. Yeah. The whole book. Yeah.
Yeah, we will do it.
Yeah. right? I'm where we say promises.
No, this one's serious.
I'm where we say promises and you swear something. I keep that.
Now we could use one.
All right, let's skip. Can't find the book. I can't find the I want to go and get the next book and now.
Yeah, I would think.
All right. So we'll wrap up there. Next day, we'll continue with electricity. We have more quantities to learn, power and energy. And then we'll learn about fuses and all those things. Okay. All right, online. You all can log out. All right, online. You all can log out. I'll see you all next week, please. All right. Bye, Samira. Bye.